Hi children, in previous video we learned the shapes rhombus and a rectangle, and now we are going to discuss about square. We all know the basic things of the square. All four sides are equal, all the four angles are equal, all the four angles are 90 degree. And apart from that, we are going to discuss about the diagonals. Can you say the measure of both those two diagonals? Yes, the two diagonals will be of equal measure and they will bisect one another. Okay, and they will also be perpendicular. So combining all these 3 points together, we can generally say that the diagonals of a square are perpendicular bisector of each other. Shall I say square is a rhombus? Yes, square is a rhombus. Every square is a rhombus. Is every rhombus a square? No, surely not, because a rhombus will become a square only if the angles are 90 degree. Otherwise, it's rhombus only. We cannot categorize under square. But all the squares are a rhombus. See here, it's like a rhombus. If I place it in a different angle. Okay children. So the next thing is, here is a chart. Can you say one common thing in all these shapes? Every shape here has one common thing. Can you say that common? What factor is common in all these diagrams? It's about some parallel condition. Can you guess? Yes, my dear children. In every shape, at least one pair of sides are parallel. See here, these two sides are parallel. These two sides are parallel. Here, these two sides. Everywhere, at least two sides are parallel. Except in the figures colored yellow, both the sides are parallel. So, if at least one side is parallel in the sense, what is the name of that shape? Yes, trapezium. So, all these shapes are trapezium. How many kinds of trapeziums I have listed here? 9 trapeziums are there. Every trapezium has its own uniqueness. See here, both the angles, base angles or acute angles. The above angles will surely obtuse angle only. Okay, so it is an acute trapezium. What about this? Here two angles are 90 degree. If one angle is 90 degree, surely the other angle will also be 90 degree in a trapezium. Is it clear? If I change this angle to be some other angle, then it will lose its parallel condition. If I tilt little bit, no, it will become an acute angle. If I make it little bit bigger, it will become obtuse angle and it will lose its parallelity condition. Okay children, so it is right trapezium. Here, opposite angles are obtuse angle. Here, what is the difference between acute trapezium and obtuse trapezium? Adjacent angles are either acute. Here the adjacent angles are obtuse. One pair will be acute. One pair of adjacent angles will be acute. One pair of angles will be obtuse. Such a trapezium is acute trapezium. If the opposite angles are obtuse, opposite angles are acute. Are you able to see the difference between this trapezium and this trapezium? Here opposite angles, here adjacent angles, neighboring angles. This is obtuse trapezium. Is it clear children? Here in isosceles triangle, the base angles will be equal. Same, it is of acute trapezium only, but the angles will be equal. So the sides will also be equal. The non-parallel sides will also be equal measure. If this is 3 cm, this will be 3 cm. If the angle is 30 degree here, here also 30 degree. Is it clear? So every isosceles trapezium is a acute trapezium. Every isosceles trapezium is a acute trapezium. Is it possible for obtuse trapezium to be isosceles trapezium? No, obtuse trapezium will not be an isosceles trapezium. Isosceles trapezium cannot be obtuse trapezium. You should not to say the statement in both the ways. Okay, now here, this is something special. It has no name, but all the three sides are equal. So it is also an isosceles trapezium. Along with that, this side is also equal. We can categorize this trapezium under isosceles trapezium only. Is it clear, children? Now coming over to this right trapezium, if I make the other angle also right angle, the acute angle is there now here in this trapezium. In this right trapezium, I have one acute angle, one obtuse angle. If I make that acute angle to be 90 degree, if I minimize it, what shape do I get now? Rectangle. So, rectangle is a right trapezium. Rectangle is not an acute trapezium, cannot be an acute trapezium. Is it clear? That's why we have this red color flowchart. With the help of this flowchart, you can analyze the similarities in this trapeziums. See here, every square is a rectangle. One more thing. Every square is a rectangle. Opposite sides are equal. All the angles are 90 degree. It satisfies the condition of rectangle. So square is a rectangle. Square can be a rectangle, but rectangle, all rectangles cannot be a square. A rectangle will become a square only if all the four sides are equal. With a condition, this rectangle will become a square. So square is a rectangle. Though the flowchart is from top to bottom, it means in the reverse way. See, every isosceles is an acute trapezium. Every square is a rectangle. Every rectangle is a right trapezium. Do you understand how I mean to say here? Okay, now when we come to this parallelogram, every parallelogram is a obtuse trapezium. See here, if I make this angle also, if I make these two opposite sides to be equal, it becomes a parallelogram. If I make the obtuse trapezium's parallel sides to be equal, then it becomes a parallelogram. So every parallelogram is an obtuse trapezium. Every rectangle is right trapezium as well as a parallelogram. Here parallelogram, from this I can say rhombus is also a parallelogram. See, the square is the only shape which acts, which can be said as every square is a trapezium, every square is a rectangle, every square is a rhombus, every square is a parallelogram. Is it clear? But if I say every parallel is a square, it is false. Is it clear, my dear children? This flowchart will help you to answer the questions stated in true or false statement. Okay, children? Shall we go in for that? All rectangles or squares? False. All rhombuses or parallelograms? It is in exercise 3.4, first question. Okay? With the help of this previous slide, try to answer all these questions. All rhombuses or parallelograms, true. All squares or rhombuses and also rectangles. All squares or rectangles, all squares or rhombuses. Just now I showed you, no, square is in the bottom of that flowchart. So it acts like trapezium, parallelogram, rectangle and as well as rhombus. All squares are not parallelograms. Just now I said all squares are parallelogram also, isn't it? So it is false. All kites. In that flowchart, the only shape we missed is kite. Kite is a quadrilateral. But it doesn't comes under the category of trapezium because they don't have parallel sides. It is different from trapezium. Hope you understood. All the other shapes comes under trapezium. Only this kite will not come under trapezium. So all kites are rhombuses? False. But rhombus is a kite. So the next question is, all rhombuses are kites? True. Here all kites are rhombuses? False. Hope you understood the way they are asking this. All parallelograms are trapeziums? True. All squares are trapeziums? True. All rectangles are trapeziums? Okay. Here you will get a question in the form of MCQs. Okay. Which of the following statement is false? A square is a rectangle whose adjacent sides are equal. Yes, this is a true statement. A square is a rhombus, of course. whose one angle is a right angle. Not only one angle. If one angle is 90 degrees, surely all the four angles is going to be 90 degree in a rhombus, isn't it? So square is, this is also a true statement. The diagonals of a square bisect each other at right angles. Yes, of course, this we learnt as a property. What about the last one? The diagonals of a square do not divide. Surely the diagonals will divide the square into four equal parts. They have stated here do not divide. So this is the false statement. The next question, which of the following statement is again false? All the rectangles are parallelograms. True. All the squares are rectangles. True. All the parallelograms are rectangles. All the parallelograms are rectangles. This is the false statement. All the rhombuses are parallelograms, of course. Okay, children. The next thing is, explain why a rectangle is a convex quadrilateral. You all know that all the diagonals lie inside the quadrilateral. So this rectangle is a convex. So you should write 2 points. A rectangle has four sides, so it is a quadrilateral. Second point, all the diagonals of this rectangle lie inside that rectangle. So it is convex. Therefore, it is a convex quadrilateral. Is it clear, children? The next question is, ABC is a right angle triangle and O is the midpoint of the side opposite to the right angle. Explain why O is equidistant from A, B and C. See, they are talking about only this triangle. They say O is equidistant from A, B, C. It means OA is equal to OB is equal to OC. Equidistance means the distance between these 3 points with O is equal. So that is called as equidistance. To prove it, they have helped us with this dotted lines making a rectangle. How to prove it? Since the right angle triangle ABC makes a rectangle ABCD by the dotted lines, OA is equal to OB is equal to OC is equal to OD. Diagonals of rectangles are equal and bisect each other. This is the important point. Diagonals of rectangle are equal and bisect each other. See here, it will bisect each other. So OA is equal to OB is equal to OC is equal to OD. That's all. With that statement, we completed the solution. Hence, OA is equidistant from A, B and C. And this is the summary of this whole chapter, my dear children. It is in your textbook. Have a thorough knowledge of all the shapes and all their properties and the common properties, everything. Okay. Here is one more question for you. The sum of internal angles of a polygon is 10 right angles. Then the number of sides is dash. Read the question. The sum of internal angles of a polygon is 10 right angles. It doesn't mean that they have 10 angles. 10 right angles in the sense 10 into 90. 10 into 90 is 900. So the sum of internal angle is 900. That's what I should mean. And this 10 right angles will not mean it has 10 angles. That polygon, if it has 10 angles, it will have 10 sides. But they didn't say the polygon has 10 angles. They are saying sum of them. So what is the formula for sum of the interior angles? Yes, it is n minus 2 into 180 degree. And it is equal to 10 into 90. 10 into 90. This is from the question. 10 into 90. Okay. If I write this 10 into 90 in the form of this, I can find n. You can just simplify using linear equation method and find the value of n. In simplest way now, I can make this as 5 into 2. So this 2 will join with this 9 and you will get 180 degree, that is here. So in the place of n minus 2, I have 5. N minus 2 is 5. So what will make n? Yes, only if I have n is equal to 7, we can have 7 minus 2 as 5. So 7 is the right answer. Is it clear, children? You can simplify using linear equation method also. Multiply 180 into 9, 60, then 900. Transposing, everything can be done. Here ABCD is a parallelogram as shown. In the place of equal to, they will give the measure of the other half of the diagonal. You have to equate it and find it out. So you will transpose and you will get y value first. And you will substitute this here and you will get the value of x. So y first you have found. So if you have an option 5, 3, don't click that. 3, 5 will be your answer. Is it clear, children?